Welcome to the ASABE member hour, Transforming Food and Agriculture to Circular Systems. I'm Chuck Roth, and I'm currently serving as past chair of the ASABE Membership Development Council. We'll get rolling with the bulk of the presentation in a few minutes, but first we'll go through a few background notes, kind of some session ground rules, and some speaker introductions. So as a background, ASABE member hours were started this last year, kind of as a mechanism for our members to meet, connect, and grow. Some have taken different formats, but in today's case, it will have some members sharing their work with the group with the goals of kind of growing the community, both in depth and in breadth of knowledge on the topic. We'll meet others with some of the same passions and kind of open up a conversation on the topic at hand. For today's hour, a few general, likely familiar ground rules for Zoom meetings of this size. First, please keep your audio on mute for the entirety of the presentation. And if you do have questions, feel free to place them in the chat feature, and those will be discussed during a moderated Q&A segment at the end. And this meeting will be recorded. I think you probably already saw the notification on that, and it'll be available for later viewing through the ASABE website. Today, we're honored to be joined by Dr. Sue Noakes and Dr. Jim Jones. And just as a manner of introduction here, Dr. Noakes is a professor and associate dean for faculty affairs and facilities at the University of Kentucky. Among a variety of other experiences and accolades, she was the Biosystems and Agricultural Engineering Department chair at that university for 6 years. She also served as ASABE president in 2019 to 2020 and is a fellow within that society. Notably, during her tenure as ASABE president, she jump-started the circular systems conversation by hosting Joel Mackauer at the Society's annual international meeting for a presentation entitled From Here to Sustainability. In addition to Dr. Noakes, we have Dr. Jim Jones today, and he is a distinguished professor emeritus at the University of Florida in the Agricultural and Biological Engineering Department. Again, among many other achievements, he is an ASABE fellow, a member of the National Academy of Engineering, and after Dr. Noakes jump-started the circularity conversation a few years ago, Jim's played a key role in carrying it to where it is today, hosting several forums and also guiding ASABE's efforts to engage in the conversation and leverage our members' expertise in biological and agricultural systems. So please join me in welcoming Dr. Noakes and Dr. Jones to the first of our 5 member hours that are going to be focused on circular systems. Dr. Noakes, I'll turn it over to you. And
thank you, Chuck.
Thank you.
And this is so much fun getting to see all my friends, or at least their names, on the Zoom call. So welcome, everybody. We're so glad you're here. And thanks to Chuck and his group for inviting us to talk today. And my assignment was to bring you up to date about how ASABE got to the place we are now with this topic of transforming ag and food systems to circular economies. So the story starts like 3 years ago when I was the president-elect, the way Keith Tinsey is now. And my responsibility was to find the speaker for the next annual international meeting. And I was approached by Jim Jones and Malit Verma, who said, we need to do something that will elevate the profession of bio and ag engineering. Jim Jones was coming off a stint with the National Science Foundation. And one of the things he told me was that it was challenging to work with people who hadn't really heard of agri and bioengineers. And so one of our goals for this topic is to just become more visible within the professional societies and within the ag industries and just in general in the ag and food systems. So we wanted a big topic, and we knew we wanted something with agricultural and food systems. And we weren't sure. We started out with sustainability as the topic, and then Jim did some research and said, wow, you know, we really need to go with circular economies. And so that was his idea. circular economies. And Joel Macauer came and spoke, and we had a panel after that at the meeting that was really interesting and went really well. And so then Jim came up with the idea that we should ask the National Academy of Engineering to do a study on circular economies. Now, Jim was a member of the Board of Ag and Natural Resources, or BANNER, for the National Academy of Engineering. So he knew how that system worked. And he got us an audience with the committee, with the Board of Ag and Natural Resources Committee for National Academy, I guess it's of Engineering, Science, and Medicine. So ASABE got interested in this topic because we think we're uniquely positioned to liaison between many stakeholders. As you know, our discipline works across many of the systems involved in the complex food and ag system. And we have members working in every piece of that, in all our different communities. And in our day-to-day work, many of us collaborate with other disciplines, with many other different ag science people and different engineering disciplines. And so we have the experience working with the system from a systems perspective, and also in a convergent manner, working with a lot of different disciplines to get our job done. So this circular economy, we believe, needs a true systems level change if we're going to really have any effect. My dog decided to walk around. So if we're going to have any effect on this, on the food and ag systems, we need a true systems level change. And that requires working with the broad range of stakeholders that are involved in the food and ag systems. And if we're going to have transformative change, it's crucial that we involve stakeholders that are outside of the food and ag systems and the traditional sustainability community. We need a broad base that can support this topic. So we approached Banner and we asked them if they would be willing to do a National Academy report or roadmap on circular economies in food and ag systems. And the reason we did this is because the National Academy's reports, they influence the national research priorities. And that's one way to get a lot of stakeholders involved, is if we have research priorities that are on this topic. And while Jim was at NSF, the Infuse competition was released, and that's the nexus of food, energy, and water. And that was the first time in 26 years of working at the University of Kentucky, I had people contacting me and saying, what do you know about ag and food systems? Because the other engineering disciplines wanted to apply for this money. And they understood that, they needed to work with people in agriculture. And so that program was a really large influence in getting food, energy, and water nexus to be in the limelight across the country. And you still hear people talking about that, and many different disciplines talking about that. So that's kind of the idea behind why we wanted Banner to do a study. Now, what's the role of ASABE? Because if Banner does the study, we don't do it. It wouldn't be us doing the study. It would be Banner forming a committee, and we can enable convergence. So we can help find others willing to support the effort. And we can also help find other societies and industries willing to provide a little bit of money to support this research, because these studies are not cheap. And we're also very aware that we need a convergent solution. So we're also very aware that we need to spread the wealth around and work with many other disciplines. And the other thing ASABE can provide is assisting with developing standards. We have a long history of developing standards for ag processes, not just equipment, and working with other organizations to make this happen. these circular systems will need approved standards and guidelines to set the bar for expected action. And so right now, what we have seen is that in circular economies, industry is essentially pulling this effort because the consumers are demanding it. And some of the solutions, at least that I have seen on the internet, may or may not contain much science. And we really want science to be involved in the solution for circular economies and for, improved sustainability. So that's another motivation for ASABE to get involved, is to bring science to the table, to work with the industries, and to work with all the other stakeholders. So, and the other reason we got involved is there really aren't any others in this space that are working at the scale we need. Some are working on pieces of the system with circular economies, and there's several disciplines, but nobody that we know of is tackling the systems of systems with true engagement of all stakeholders. So that's really our idea. And, with Dr. Jones's help, this thing keeps growing. Right now, most of the work has been done external to ASABE, as in with other stakeholders. And one of our intents is to work on getting the internal piece so that all our ASABE members who are interested can get engaged. But right now there's a lot of external excitement about this. And on September 9th, Dr. Jones and I participated on this National Academy of Science, Engineering, and Medicine seminar. It was called Focus on Systems, Circular Economies for Food and Ag Systems. And there were over 800 people from across the world watching this, and an amazing variety of disciplines too. So that was just pretty exciting, because all the way through this colloquium, ag and bioengineering kept getting mentioned, because we sponsored part of that seminar, and also a lot of the people who were speaking were ag and bioengineers. So that definitely at least got our name out there in a big way. So now I'd like to turn the podium over to Jim, and he's going to give us more technical information on circular economies for food and ag systems.
Thank you, Sue. I'm going to share my screen here, if this works okay, and put it in presentation mode. Okay, does that look okay?
Looks great, Jim. Thanks.
Okay, well, Sue, you did a great job. Sue just reminded me of a lot of the different steps along the way, and I hope that her comments helped excite all of you about the opportunities that this provides for our professional society, and for those of us who are individuals working on some components of it. And it's not like everyone should expect to work across the full system of systems, but as Sue indicated, this approach, we feel, is a way to help unify the thinking as we look toward transforming our food and agricultural systems. And so today I'll talk about several things. I want to mention at least some of the grand challenges to start with that we talked about at NSF. And by the way, I'm back at NSF part-time now, so I'm seeing some strong interest there in these topics as well. But I want to talk about the grand challenges, and then relative to food and agricultural systems, what does that mean? And then the importance of transforming these systems. Just a brief introduction to circular economy concepts, and then go through some of the ASABE initiatives like Sue was doing already, and maybe give just a little bit more information about each one, but I think you should have the overview already from hearing what she talked about. So first of all, there's some real critical challenges that we face, and the population growth, for example, the 9.7 to 10.9 billion people by 2100, and climate change. There's more awareness of this now, more certainty that it is a major problem that we need to deal with, both on adaptation but also mitigation. And I know some of you are working on mitigation relative to food and agricultural systems. Urbanization is going to continue to be an issue. And one of the things that has been talked about quite a bit is that our resources are also being drained at an alarming rate. And this is from Steve Hawkins. And all of these things are happening simultaneously. And then, so what does this mean for food and agricultural systems? Well, it means that the demand is going to increase. More food production is going to be needed by 2050. And there are limited and declining natural resources, and that means arable land, water, fossil fuels, phosphorus, biodiversity, ecosystems, and so forth. Agriculture already uses about half of the habitable arable land and over half of the fresh water that exists on the earth. It's highly vulnerable to climate change and epidemics, as we've seen with COVID-19. And you know, farmers and on the production side put a lot of effort into producing the food and other products, and we now know that between 30 and 50% of food waste is discarded and goes into landfills. And this causes degradation of water through nitrogen pollution, greenhouse gas emissions, and ecosystem health generally. So there are major problems that we face on the earth and also in our food and agricultural systems. Stepping back a little bit though, the US food and agricultural systems are highly impressive, and they're technologically advanced. They provide safe and affordable products that we take for granted. And such a small fraction of our population is engaged in farming systems. Most people aren't really aware of these advances, but they're very safe and affordable products. But I wanted to point out also, as to follow up on what Sue was talking about, we're talking about systems, and we're considering supply chains that encompass farming, processing, packaging, and waste activities, all of the things that happen along the value chain, including facility development and all the processes. And these are highly valuable. They create a lot of economic activity, and they employ many people. Over 28% of the US workforce employed by our food and agricultural systems. But there are complex interactions that occur across the food chains. And you know, some of these interactions are with energy and water, as Sue pointed out, the Food Energy Water Nexus initiative that NSF and USDA is still funding projects on that. Very good program. And food security is really important for us, and all of us know that, perhaps even more so now after the COVID shortages that we experienced than before. Science and technology innovations have enabled these impressive gains. genetics, fertilizers, facilities, automation, sensors, IT, different business operations. And we've had favorable incentives and policies that have been designed to increase and stabilize our food supplies over the last. But here's the catch. These impressive gains have occurred without adequate consideration of the degradation of water, soil, atmosphere, and ecosystems that comes with it. Now, I don't want to overstate that, but they're really very important. And as we get more crowded, as the earth gets more crowded, I think we're seeing more and more examples of where this is a real problem that we can't really afford. The National Academies of Science, Engineering, and Medicine has recognized this, and they've recently put out 5 different reports focusing on food and agriculture. Or in one case, it was focusing on environmental engineering. And one of the top things they listed was the importance of food and the interactions with the water resources and the need to consider these systems. And these reports, the National Academy of Science, Engineering, and Medicine, they provide advice to federal agencies on funding and on priorities for developing the science and engineering that's needed here in different topics, not just in agricultural systems, but also all of the sciences and engineering. In addition to that, the Rockefeller Foundation came out with a report last year on meeting the resetting the table to meet the moment to transform U.S. food and agricultural systems. So the idea is that time is now, that we should really be doing this. And they listed 5 capabilities needed in the transformed systems. I've listed 3 of these here today because they're relevant, I think, to our ASABE professional society. True cost accounting. And of course, this interacts with other disciplines as well, but this includes not only the direct costs, but some of the indirect costs that occur due to external impacts that are not wanted, but tend to happen anyway. Another one is to modernize the data and technology platforms to provide tools to efficiently operate systems more effectively. And then to unify actors across multiple sectors, including food and agricultural systems. And so food unification of our actors is one of the things that I think we can start with in ASABE, because we have ASABE members working all the way from facilities development to production to harvesting, drying, processing, transport, and waste management. So it's not like they will all be working together, but at least they will have a common set of principles and goals that they're looking at as they think about transforming the parts that they're working with. So we have to transform these systems. Most of these reports have indicated that we need to transform these systems, that incremental advancements, like has been happening in the past, is not going to be sufficient for the future. And they all talk about systems approaches, but they haven't really yet talked about what systems approach. What scales do we work at? I mean, how do we really deal with all the complexities associated with our food and agricultural systems? And so we kind of got here because of this lack of circularity that we have so far in our systems, that our current systems evolved through incremental changes to increase yields and keep pace with the growing populations, the increasing demands. And this has been done, and it's been done well. But our mindset was to increase production with very limited attention to the natural resource base, the discarded resources, and the environmental and ecological impacts. So the waste that we have, that we produce, some of it along the value chain and some of it by consumers or industries that are providing food or other products. We haven't really paid much attention to capturing these trapped resources, although some of our ASABE members are doing this. They're working very hard to find uses for the resources there, either to produce more energy or bioplastics or fertilizers, transforming it into fertilizers. But anyway, addressing the combined needs of production, natural resources, and environments is inadequate and mostly missing in many cases. And that's not because many of us have wanted to make that happen. There are policy issues that are making it challenging as well. So let me talk a little bit about the circular economy principles. Our current food and agricultural systems don't really adequately consider the value of the natural resources and the environmental impacts and sustainability. They trap resources, as I've said, and by not considering the overall system, we don't really see the fact that there's a lot of interactions that are taking place that may be limiting the solutions that we might think of. And the Ellen MacArthur Foundation in the UK has done an awful lot on circular economies, not only for agriculture and food, but also for other industries, including plastics industry and transportation and electronics. If you look at our value chains down here, this is a depiction where we have input resources at the very top of the value chain. We have pre-production, operations, production, post-harvest, and consumption, and that includes waste along the way. And these wastes end up being discarded. And so that's the resources that are lost, as that I pointed out. So now we need to look at multiple societal goals as we try to transform these mostly linear systems now. And then they're listed here: increased production, that's important, of nutritious foods and other agricultural products. We need to considerably reduce greenhouse gas emissions and to become carbon neutral or capture more that's emitted, becoming carbon neutral, negative. Eliminate contamination of water in our ecosystems. Increase the stability, affordability, and resiliency of food. More efficiently use and conserve natural resources. Ensure that farmers and businesses benefit economically, or they won't adopt it. And then understand the trade-offs among these different goals, because there are many, and that's been part of the problem. There are trade-offs that we don't really take into account very well. Some of the agricultural industries are working on this already, as Sue pointed out. This is one, the U.S. Farmers and Ranchers in Action organization have done some studies. Solutions from the Land is one of the groups that ASABE is already working with. And they've done studies to show that this is really needed now. So here, so the how we do this, I mean, we need to consider systems approaches. We need to have convergent processes, and we need to transition toward more circular systems. And there are basically three principles that have been used to inspire redesign of systems. And these are listed here. Keep products and materials in use. design out waste and pollution, regenerate natural systems, and then we've added one here to also provide economic benefits. We've done some studies that I'll talk about a little bit more later on in ASABE to see that if these transformations occur using these principles all along the value chain, then a key outcome of those processes will be increased sustainability, high resource use efficiency, and less waste. One of the things that NSF and others are talking about now is a world without waste. And so what can ASABE do to help that? We think that this approach positions us really well to take leadership or to maintain some leadership in this area. There are a lot of definitions for circular economies. It's a systematic approach to economic development that benefits businesses, society, and the environment is one that was from another sector, not in agriculture. It's inspired by nature. Nature's cycling of water and biological products sustains the earth. And so what we need to do is transform our systems from these mostly linear systems into these circular economies to try to use these principles that I mentioned earlier as we rethink and re-engineer the different components along the value chain. Sue mentioned standards. You know, one of the things that ASABE and other societies are thinking about, and industry too, is traceability. Traceability of food, for example. So that means there has to be some information technology used there. This slide lists some of the other important characteristics of the products that we produce in our food and agricultural systems that need to be taken into account in order to do the accounting for the circularity, for the energy usage and greenhouse gas emissions and fate of nitrogen and phosphorus in our environments. And so we need standards and performance-based metrics in order to do this. And this is one of the things that one of the speakers last week followed up in an email with me, is that we really need to have these performance-based metrics. And that's something that I think ASABE would be well positioned to do. When we started looking at this, Sue and Violet Verma and several of us, we looked in the literature, and there are groups around the world that are doing this back then. That was 2 years ago. Most of them were in Europe. Some of them were in China. The Netherlands actually adopted as a national priority the transformation of agricultural systems into circular systems. And so they've got a number of publications there. But not only research organizations, there's growing interest in industries. Many of them are, like Sue said, they're already ahead of us in academia. There's a Verge Food. This is the speaker that we had in 2019 in Boston, Joel Mackauer. They have an emphasis on food systems now. Land O'Lakes, Microsoft, a number of different food companies and other businesses, including cotton industry. And as Sue pointed out, the national academies and ASABE and other organizations and agencies are keenly interested in this now. Until now, there have been limited academic efforts, and that's because I think there's not been much funding that says, okay, help us define this and create teams. Well, that's changing now. One of the speakers last week is at Rochester Institute of Technology, an environmental engineer. And she has now a $15 million project to work on eliminating food waste in the state of New York and interacting with other networks as well. Some of the things that we found when we were looking is that there are partial solutions towards circular economies in different places in the U.S., including some of the vertical farming and the solar panel, solar roofs of greenhouses, dairies, aquaponics, and so that was kind of what we started with when we looked, and we said, "Oh my goodness, you know, this is something that our profession can really contribute so much to if we just can organize ourselves and really develop the right kind of connections and partnerships." So here's a list of some of the ASABE activities. Sue went through most of these, so I won't spend much time on most of them, but the ASABE Board of Trustees adopted as a long-term priority the transformations to food and agricultural systems into circular economies. That's a priority that's still in place, and we're working on that now. And then a successful proposal for the Board on Agricultural and Natural Resources. And they're still planning this study. It's a really expensive study, and it's still going through the approval process. I think it's approved internally, but now they're just finally trying to put that together. This is, and I won't go through this in detail, but this is the perspective that we submitted to Banner to propose that study. Sue and Lalit Verma and I were all part of the team that presented it there, all ASABE members. Then Sue appointed a roundtable for internal study in ASABE. And that was led by Brahm Verma, who's with us today as well. So Brahm, people may have more questions about this later on, but one of the things that came out of that was that we had a special issue of the resource periodical. And I think probably many of you, or maybe all of you, have seen that. But these studies were done strictly by ASABE members. And by the way, we had a couple of new members who just joined ASABE because they were excited about participating in this kind of effort. And so Sue Noakes and I on the first chapter, our first paper, and then there are other ones that deal with fresh tomato. Katie Migliaccio in Florida and Claudio Stockel in Washington State led that study on cellular beef. Norm Scott was a champion of that paper that really focused on that. And by the way, we had one of our speakers last week, if you didn't attend that, was one of the vice presidents from Upside Foods, and they're producing this cellular beef based on synthetic biology designs. Bruno Basto is one of the new members from Michigan State, and he and I worked on designing circularity into corn soybean systems. I'll talk about that more, but then there's vertical farming. Casey Ting at Illinois. I mentioned the tomato, and then we had some reports also on animal systems, livestock systems. All of these are different, and so it's not like we can just apply these principles the same in every system because the problems and the issues and the challenges are different depending on the food chains themselves and where the production takes place. I'll speak just a little bit more about the one that Bruno Basso, myself, and economists and others worked on, and that's on corn soybean systems. And so Bruno led this, saying our current production is not sustainable. We have a lot of field losses of nutrients. We have greenhouse gas emissions, a lot of energy required for production, drying. It's also emits greenhouse gases. And doing a life cycle analysis on this, you can easily see, where a lot of these greenhouse gases are coming from on a typical farm in the Midwest. In addition, there are low efficiencies of nitrogen uptake on average, a lot of nitrogen leaching from the Midwest fields, and they contribute to water pollution, and including even in the Gulf of Mexico. And then the food loss that occurs from that. And so Basso and we had one of the papers in that resource, and you may have seen that. We also published a paper in Agricultural Systems after that went further, and it describes it in more detail. And I've got the citation for it here. And this is an image of the interventions that can take place that go all the way from taking some of the land out of production that are less productive, using digital agriculture, precision agriculture, and then creating energy on the farm, either using it on the farm or putting it back into the web, into the grid. It may be increasing fertilizers in some of the spots where the soil is really going to make use of it, and the plants can take it up and increase the production there. So it's really a nice idea. This is Basso's idea that he started with, and we just kind of embellished it with taking into circular agriculture systems. And so this tells us that even working with production subsystems, which meant, all of us work on some systems and are subsystems of other systems. And so what this tells us is that you can work on subsystems, with the same principles, and you can make progress toward meeting the needs of the broader food chain. But it's important to to consider the full food chain. This is some of the things that I won't go in detail, but it talks about a transitioning, making use of some technologies that are available today, and then going into more that are expected in the future. We've had discussions with ASE 16 on standards. There was a mini symposium in the AIM meeting this year, ASABE sponsored, and then there's a special transaction of ASABE issue on circular systems that Katie Migliaccio is organizing. And then this member hour series, and again, I congratulate the organizers of this type of event, not only for today, but I think in generally it's great. ASABE sponsored was one of, I think, 6 or 8 sponsors of the National Academy of Engineering forum that we held last week. And I've got the website there where that program is, if you haven't seen that, and they should be coming out with the recording of that later on. And then most recently, ASABE has assigned a task force for studying how to really propagate these ideas and concepts internally in ASABE programs across the society, not just any one community, for example, but then also connecting with other societies and organizations externally. And So that's just been done. I'll be chairing that committee, but Paul Heineman has got commitments from a number of people to help with that, and I'm looking forward to working on that in the future. Now, this is a diagram that goes beyond the food chain or the value chain of our supplies. It says other perspectives and scales are important. When I've talked with our economist colleagues, you know, they say, well, yeah, but you're only considering supply, and you're not really considering the demand and how these supply and demands maybe interact over scales from local to global. And so all of these things are important. And fortunately, we have a few economists that are highly interested in this, and the Agricultural and Applied Economic Association was also one of the sponsors of our National Academy of Engineering event last week. And so anyway, I think that's my last slide. This is my last slide, and I'm just going to leave that there. And maybe we have some time for some questions or additional comments from Sue or Katie or Bram or someone else who might want to make a comment or ask a question. So Chuck, let me stop that, and I'll stop sharing now as well. And by the way, I'll send this PowerPoint to you, Chuck, and Jasper, and you know, feel free to share it.
Sounds great. Thanks. Thanks, Jim, for that presentation. Looks like we really haven't had too many questions or haven't had any questions in the chat window yet. Please do drop those in there if and when you have those. Actually, one just came through. I'll just kind of read it and send it over your way. Oh, actually, a couple of them are coming through, so I'll try to work my way through them here. So forgive me if I miss them or mispronunciate something, or you know. So the first question is, how do we measure circularity in an agricultural and food value chain? What are some of the key performance indicators or measurements that we can monitor and control that would indicate the circularity?
Well, I'll take a stab at that. I mean, it seems that the variables that I put on the slide earlier, the carbon, nitrogen, energy footprint, water footprint, the land footprint, all of these are important attributes. And you know, I know now that a lot of folks in food engineering, for example, are working toward traceability, tracing where the food was produced or the product was produced. I think we need more than that. I think we need to have information there that will allow each subsystem along the way to take the information that they're provided in terms of tracing the carbon footprint, the nitrogen footprint as it goes through its value chain. And that doesn't exist very well today. I think that's where this performance-based metrics comments are coming from. Some people are working on that. I think there's been at least 1 or 2 papers on quantifying circularity per se. But it's those elements, it's those characteristics that can be seen or thought about when you're doing life cycle assessments and modeling these different systems that are important.
Another question came through: should soil be one of the necessary inputs?
Absolutely. Soils are critical. In fact, one of the principles is regenerate natural systems. And of course, those of us working in agricultural production systems, soils are critical. And that means, you know, providing it more carbon, more organic matter. And that does a couple of things. I mean, it helps restore the carbon sequestration. It helps sequester carbon. It increases the water holding capacity of soils and the overall ability of plants to mine the nutrients there. So yes, soils are very important.
Another question, a couple more questions here. First is, what are your thoughts on applying circular ag to urban agricultural systems?
I think that's really important. One of the major emphasis of the National Science Foundation now has been on sustainable urban systems, and they include food as a part of that. There's a lot of vertical farming efforts going in now, and these systems, they can measure in their system and quantify that they use only 10% of the amount of water that's used to produce a given mass of product that's used under field conditions for growing vegetables, for example. And so there's a lot of technologies that can be, I think, developed in that, but there also are problems, in terms of energy requirements for vertical farming. So people are beginning to work on that. I mean, Casey Ting or others who have been working on these controlled environment systems may be able to provide more insight to that. But yes, it's very important. It's recognized now as being highly important, and not just the vertical farming things in terms of urban areas, but also the peri-urban areas that supply food to cities. Lots of work is going on there. Food waste is another huge one in urban areas, of course. So yes.
Thank you. Another question here. One slide stated that as we rethink SAF, farmers and businesses must be able to make a profit. It sounds like a politically safe condition, but is it entirely true?
Well, it's a very good question. I mean, that's got to be part of the considerations as we rethink these individual systems. Part of the reason that some of them aren't true now is that there are disincentives for farmers to do certain things. One of the people involved in these studies was Bruno Basso again, and he's got a project now working with farmers and working with the NRCS to look at ways of changing some of the incentives that are there now, so that the resulting transformations and transitioning process will actually make a profit, could be profitable. So we don't know how that is, and it's not something that we just included to be politically correct with certain crowds. I mean, we really believe that all of us in ASABE, I think, have to embrace that. But to look beyond just the current systems that we have, reimagine the future and think about how not only technologies need to change, but also some of the policies and incentive structures that we have.
Let's see, a couple more questions, and then we'll kind of wrap it up here. First, chain of custody or traceability and transparent labeling for ingredients are excellent proposals. Does ASABE work in that area? And if so, what are some of the key obstacles?
Wow. I can say that there has been some work. I'm not familiar with it in detail, but at University of Florida, I think there's one person who's working on traceability somewhat. But I don't know the details on that.
Okay.
Maybe Sue or Katie or someone might be able to shed some light on that, or Brahm, I don't know.
Jim, this is Brahm. John Ruff from the IFT is leading the effort on traceability on food systems. I do not know details of it, but IFT has a special assignment and a special office primarily for traceability. And John is the one who's leading that effort.
Okay, thank you, Brahman. Yes, IFT was one of the ones involved in the AIM meeting as well, and we've had some very good discussions with them about extending what we're doing in ASABE and working outside our professional society to go to the other professional societies like economics and food technologies and others.
Let's see.
Any other questions?
There were a couple more. One that's already kind of been touched on. I think Steve Searcy, I think we kind of touched on that. Right in if you see otherwise. I think Jim kind of spoke about is about approach to regulation versus alternative approaches to incorporating the economic and sustainability items together, trying to make those meet together. Is there so I guess the question is, today we're looking at regulation. Is there a better way to look at it? And you kind of touched on that, Jim, I think already.
Well, in the paper that Bruno Basso and several of us wrote, there are some alternative ways there as well, but it involves things that typical farmers aren't necessarily doing right now, and whether they would adopt these or not, it's just like we have to work with farmers, and we have to work with food suppliers and product suppliers of different kinds, and so I think you need all of the above. I mean, to me, this is an all hands on deck kind of problem. It's almost like the moonshot. Someone else mentioned that, I think last week. It's going to take all of us working on our pieces and communicating with the other people doing their things. And I see Norm Scott's intervention there, which I agree with. He said, I would like to suggest that the word toward precedes circularity, just like for sustainability, because nothing is completely circular or sustainable. Fresco made this point last week. Yeah, she's the president of Wageningen, and that's exactly right. And part of it's because our systems, once we disrupt nature, we can no longer be exactly putting things back where it was to recycle those. And so we have to be inspired by these principles and go toward them, as Norm pointed out there as well. And that's what we really aim to do. And how far we can go, I don't know, but I think we've got the minds in ASABE and our other professional societies and industries and academia to address that. And I think a lot of eyes are on ASABE now because of all the exposure that has been gained by the things that ASABE Board of Trustees did, the National Academy study. Last week, there's a lot of follow-up things that we're looking at as well. But I wanted to say this too, though, Chuck. I know a lot of you, and I've known a lot of you for a long time. Not all of you, but I'm really proud of our professional society, and I think it can do better by having all of us look at our own problems that we're addressing and try to look at it in the context of more complete systems. And I think that's really what we're aiming for here, is to try to get the members in ASABE to think, to help us think how this can be done best within ASABE and how we can then go beyond there to other professional societies. We're perceived right now as being the lead profession that is pushing this in the US. And so I'm really pleased about that. It's also a real responsibility to have, because I think it's going to happen anyway, but I really hope that we're part of it. And so far it looks like it's very positive.
All right. Well, there are a few questions out there remaining. Unfortunately, we don't think we can cover them all today in the time we have. We will carry some of those over. We do have a few. We have 4 more events in this series, 4 more member hour events. I think the next one is coming up here in a couple weeks. In general, it's not a rule, but in general, they're going to be looping around every 2 weeks. We'll have another one here with a few breaks in there for different U.S. holidays and the like. But before we go today, I wanted to just give a special thank you for your participation, everybody on the call, and a special thanks to our speakers, Drs. Noakes and Jones, and Jasper for helping out, kind of being a co-moderator, and as well as several others that helped make today a reality. And we're looking forward to seeing everybody again here in a couple weeks. There is another member hour that kind of dives in a little bit deeper into a few of the topics within circularity over the next couple of months. So this is the first of a 5-part series. And so please join us for that second installment. That's going to be specifically, it's going to be on Thursday, the 30th, September 30th at 1 p.m. Eastern. So same time. There's a registration out there as well on ASABE's website. Dr. Qualfie will be discussing when circularity becomes central to our global food security agenda, specifically focused on the rice value chain. And so I think Jasper dropped a link in the chat there that you can go there and register, and it'll be on Zoom again. So we look forward to seeing you all at that time. Thanks everybody, and we'll carry these questions forward as well.